Okay, so Pythagorean theorem, as you know, Pythagorean theorem is a squared plus b squared equals c squared. And it's only used for right triangles. It only works for right triangles. So here in our example, we have a right triangle. This little square means that this angle is 90 degrees. The sides of the right triangles are called legs. So the two adjacent sides to the 90-degree angle are called legs. So this is a leg, and this is a leg of the triangle. And then the side opposite the right angle, so here's a right angle, the side opposite that is called the hypotenuse. The hypotenuse is the longest side of a right triangle, and you can always identify it because it's opposite the 90-degree angle. Okay, in terms of Pythagorean theorem, this would be a leg, and then C is the hypotenuse. And the legs are interchangeable. It doesn't matter which one is A and B, but the hypotenuse has to be C in the equation. Okay, so reviewing how to use this, again, if it seems easy, just let it be easy for now, because it's not always easy. It says find the hypotenuse, so we have our two legs, A and B, and then this would be C, and then we're going to use Pythagorean theorem. So it would be 4 squared plus 11 squared equals x squared. Okay, and then from here we're going to solve it. I've done a lot of the calculations, so it goes a little bit faster. 4 squared, 4 times 4 would be 16. 11 squared, 11 times 11 would be 121. X squared. 16 plus 121 is 137 equals x squared. This is where some people kind of get stuck. It's like, what do I do now? X squared, we can't leave it like that. We have to get it by itself. So we take the square root, and whatever we do on this side of the equation, we also have to do over here. So then we get x equals square root of 137. We would simplify this if we could, but it's actually prime, like it can't be broken up into factors, which is kind of odd. And then to get the decimal of this, you can do 137 and then just hit square root, and you get 11.7. So x equals 11.7. So sometimes you'll see the answer in a square root format, sometimes you'll see it as a decimal. Of course, both are correct. Okay, then over here it says find a leg. So this is the other variation of the problem. So we have A that we're solving for, we're given B, and we're given C, the hypotenuse. The hypotenuse is always opposite that 90-degree angle. And then from here we'll set it up in this equation. So we got A squared plus 12 squared equals 13 squared. And then from here, go ahead and solve. 12 squared is 144. 13 squared, 169. Subtract 144 from both sides. A squared equals 25. Take square root, and A equals 5. So this length right here is 5. So far, so good. Okay, the next thing is probably something you probably haven't seen before. It's called a Pythagorean triple. There are common numbers that satisfy this equation, a squared plus b squared equals c squared, common numbers that satisfy this equation that make right triangles. And just being familiar with this can actually save you a lot of time. Hello? Hi. No, he's in Italy for the week. He might be back next week. I think they're getting everything. Yep, bye. Is testing. Okay. 3 common numbers that satisfy this equation. Okay, common right triangle. So we're going to draw 3 right triangles. This one, this one, and this one. Okay, so the common numbers are 3, 4, and 5. 5, 12, 13, and 7, 24, 25. So these are numbers that come up in right triangles all the time. So if you see two of these numbers, you don't necessarily have to solve for the third. You'll know it's 3, 4, 5. And then also anything similar to this would also be a right triangle. So for example, like if the side lengths were all double this, like 6, 8, 10, it would be a right triangle. Or times 3, 9, 12, 15, that would also be a right triangle. Okay, then down here. Down here we're going to just practice using Pythagorean Theorem, and it says write your answer in simplest radical form. So if we have a radical that can be simplified, we're going to use the skills that we learned yesterday. So for this first one, this would be our two legs, A and B, and then this would be C. So we'll do 3 squared plus 3 squared equals x squared. Get 9 plus 9 equals x squared. 18 equals x squared. Then you have to take square root of both sides. And here is where we're going to simplify the square root of 18. So to simplify this, just break it up into factors. Numbers that multiply to 18 would be like 9 and 2. And multiply to 9 would be 3 and 3. And then any doubles, we'll take that out of the square root. So we get 3 square root of 2 equals x. So the answer choices, if it's multiple choice, could be in this format. It could also be as a decimal. So let's say you did 18, square root of 18 is 4.2. And all the answer choices looked like that. Let's see, 4.24. Let's say all the answer choices looked like this, but you got this. What you can do is just take the answer choices, plug it into a calculator, and see if you get this. So I can do 2 square root times 3, and I'll get that answer, and I can just verify whether it's correct or not. Okay, next, number 2. We have A and B here, and they gave us C this time. So 9 squared plus x squared equals 15 squared. And just going through and solving 144. And it comes out to a whole number, which is nice. And then over here for number 3, A, B, C. 25 squared plus x squared equals 65 squared. Just have already done the calculations in the calculator to make it faster. To solve, subtract 625 from both sides, and we get x squared equals 3,600. Then the last step to get x by itself, I have to take square root to just get x, and then you have to do that to both sides. And then the final answer is 60. Okay, when you got that down, we'll flip to the next page. Okay, on the next page, we're going to review a couple things that we've seen before. Well, different things than this. So I'll show you on this page. So triangle inequality theorems. We saw this in chapter 6, so it'll be nice to kind of go over it. It says the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So when you have a triangle, the two shortest sides, so in this example, 2 and 2, added together have to be longer than the third side. So is 2 plus 2 greater than 5? No. So therefore, this is not a triangle. Not a triangle. The reason why this is because if you have two segments that are both 2 inches long, it wouldn't reach something that was 5. Like you couldn't, oh sorry, I didn't realize. Okay, so these two segments are both 2 inches long. This is 5. You couldn't make a triangle, like it wouldn't reach. So that's why this is true. And then for the next example here, the two shortest sides, they didn't put the side lengths in order, but the two shortest would be 3 and 6. So 3 plus 6, is that greater than 10? No, 9 is not greater than 10. So therefore, again, not a triangle. And then this example right here, 9, 8, and 12. So the two shortest sides, 9 plus 8, is that greater than 12? 17 is greater than 12. Yes, it is a triangle. Okay, and then over here, we've seen this before too, so it's nice to review it. It says, for these triangles, list the angles in order from least to greatest, and list the sides in order from shortest to longest. Remember, the longest side is opposite the largest angle, so we can look at the side lengths. So if this is the smallest, medium, and longest, then opposite that would be the smallest angle. So shortest side opposite that would be the smallest angle. So angle T would be the smallest. Then medium would be angle R, and then the biggest angle would be angle S. And it said to put them in order from least to greatest. So we're just looking opposite. And then for this, I know it's really tiny. Okay, sides in order from shortest to longest. So we look for the smallest angle, and opposite that would be the shortest side. Medium angle, medium length, and biggest angle, longest side. So shortest CB, medium AB, and then longest would be AC. Okay, the next concept is new, unless you got to it on Alex already. It says the converse of the Pythagorean theorem. If a triangle has side lengths a, b, and c, such that a squared plus b squared equals c squared, then the triangle is a right triangle. So just as we can use Pythagorean theorem to solve for side lengths in a right triangle, we can also prove that a triangle is a right triangle because this equation works. So here it gives us a triangle. We want to know if it's a right triangle. So we're going to set it up in Pythagorean theorem and see if the numbers work. So we have 10 squared plus 10 squared to 3 squared. Does that equal 20 squared? I know, weird numbers, but I'll walk you through it. So 10 squared is 100. That's easy. When you get to this, you might get thrown off a little bit. I'm just going to do this off to the side. So 10 times square root of 3, and it says it's squared. So times 10 times square root of 3. And so we would do 10 times 10 is 100. And square root of 3 times square root of 3 is just going to be 3. So that's 300. And 20 squared is 400. So then 400 does equal 400. So yes to being a right triangle. Okay, then down here, you guys got it all? Okay, so down here, this is probably new as well. You can also use the Pythagorean theorem to decide if a triangle is acute or obtuse. So if a squared plus b squared is greater than c squared, then triangle ABC is an acute triangle, meaning all acute angles. And then if a squared plus b squared is less than c squared, then ABC is obtuse, meaning it has one obtuse angle. Sometimes I have trouble like remembering which one's which. But to me, this makes sense because in an obtuse triangle, like you have an obtuse angle, like a bigger angle here. And it would make sense that opposite that, like C would be larger. And that's what it's showing here, that C squared is bigger than those two. And then down here, we're going to try it out. It says determine whether each set of numbers are the measures of a triangle to begin with. So we have to determine if it's a triangle by this method, and then we have to determine whether it's acute, obtuse, or right triangle. So for this, number 1, to determine if it's a triangle, we're going to take the two shortest sides, 11 plus 60, and see if that's greater than 61. Yes, that is bigger. 71 is greater than 61, so yes, it's a triangle. Then we're going to do Pythagorean Theorem to see if it's a right triangle, acute, or obtuse triangle. So 11 squared plus 60 squared, is that equal to 61 squared? 60 squared is 3,600, and 61 squared is 3,721. And so we get 3,721 over here, and that's equal to 3,721. So it is a right triangle because it's Pythagorean theorem works. Okay, so here, two shortest sides would be 6 and 12. We're going to see if it's a triangle. So 6 plus 12, is that greater than 18? 18 is not greater than 18, so therefore not a triangle. That was easy. Okay, number 3, the two shortest sides right here, 3 and 5. 3 plus 5, is that greater than 7? Yes, 8 is greater than 7. So yes to being a triangle. And then we want to see if it's right, acute, or obtuse, so we're going to use Pythagorean theorem. Use a different color. See, so we'll do 3 squared plus 5 squared and see if that equals 7 squared. We get 9 plus 25, 49. So we get 34 compared to 49. So this is greater. And when that c squared is greater, it is an obtuse triangle. So we can say obtuse. Number 4, two shortest sides, 8 plus 13 is 21. 8 plus 13, is that greater than 22? 21 is not greater than 22. So, not a triangle. The next one, actually, you know what? We're going to skip 5 and 6 because our brains are getting tired. And we're just going to do 7 and 8. Okay, so number 7, two shortest sides added together, is that longer than that? 6 plus 11, is that greater than 14? Yes, 17 is greater than 14, so yes to being a triangle. And then we'll use Pythagorean theorem. 6 squared plus 11 squared. How does that compare to 14 squared? 14 squared is 196. 36 plus 121 is 157, so that is less than 196. So the c squared is greater, so that would be an obtuse triangle. Okay, number 8, I definitely wanted to include because it has the radicals. But don't be afraid because it actually comes out, even though this looks complicated, it's not a complicated problem. So first we need to determine if the two shortest sides added together is longer than the third. So 2 plus square root of 8, is that bigger than square root of 12? You can use a calculator. Like square root of 8 plus 2 is 4.8. Is that bigger than square root of 12? You can just use a calculator. That would be 3.5. So yes to being a triangle. And then using Pythagorean Theorem to see what happens. 2 squared plus square root of 8 squared equals square root of 12 squared. So 2 squared is 4. Square root of 8 squared, it actually just comes out to 8, which makes sense. And then square root of 12 squared would just be 12. And 12 does equal 12. Cool. So that would be a right triangle. Because it's equal. And that's just all. Okay, so you have the rest of class to do homework. Right. Homework 9-1 on Schoology. And then if you finish that, work on Alex. Then Alex. Okay. Grab a laptop, get logged in. Let me know if you have questions. You guys are awesome. What is there such green joy? I don't understand that. Hey, you can do